Factoring a trinomial involves guessing and checking, and there's no way to avoid that. But you can do it fairly efficiently if you have an organized way to keep track of your guessing and checking. Since factoring is essentially the opposite of multiplying, one good way to keep track of your thoughts is to use a multiplication box. The idea of the multiplication box is that we're saying that this expression here is the contents of the box, and we're trying to figure out what goes here and what goes here. There are a few things you can know for sure right at the outset. You know that the x squared goes in this first box, and you know that the 21 goes in this corner box. And somehow the contents of this box and this box make negative 10x. So let's start with what we can be sure about. There must be an x here and an x here. Now we need to come up with two numbers that multiply to 21, and there are various possibilities, but the one that first comes to my mind is 3 times 7. Let's check the contents and see if that works. That would give us 3x here and 7x here. Now in order for the 21 to be positive, I need my 3x and my 7x to have the same sign. And if they're going to make negative 10x, they'll have to be negative. So we now have a completely factored problem. And our answer is x minus 7 times x minus 3. This particular problem was relatively simple because there aren't that many combinations to try to make 21. But let's look at some slightly harder ones on the next few pages. Here's another factoring problem to try. Once again, we know that the top left box has the x squared in it, and we can put the x's right around that where we know they belong. We also know that the negative 12 goes in the bottom right corner. Now this time we have a lot more guessing and checking to do because there are many possible ways to make 12. We could have 1 times 12, or 2 times 6, or 3 times 4. Let's try 3 times 4. That gives us a 3x in here and a 4x down here. If the signs are different, we could get 1x in the middle. Or if the signs are the same, we could get 7x in the middle. But there's no way to get 4x in the middle. So we need to erase those and try something different. Why don't we try 2 and 6? Now we have 2x in this box and 6x in this box. Now the 12 is negative, so that means that the 2 and the 6 have opposite signs. That way I can get the minus 4x. It looks good. If I make these minus and make these positive, we have our answer. So sometimes it takes a certain amount of patience with your guessing and checking to find the final answer, which in this case is x minus 6 times x plus 2. Here's another factoring problem. Let's start by putting the parts we know into the box. The 3x squared goes there, and the negative 10 goes there. Now 3x squared would be 3x times x. So let's put those somewhere. Now we need to think of two numbers that multiply to negative 10. We could use 1 and 10, or we could use 2 and 5. 1 and 10 doesn't look all that likely, so let's try 2 and 5. That gives us 2x down here. But it gives us 15x here. That doesn't look very promising at all. However, it matters which is 2 and which is 5, because the 5 in this case is getting multiplied by the 3x. So let's try putting them in different positions. Let's try putting the 2 here and the 5 down here. Now we get 5x here and 6x. That looks more promising. Now since the 10 is negative, either the 2 or the 5 has to be negative and the other one positive. That means that the 6x and the 5x have different signs. If I make these negative and make these positive, I get my negative x in the middle, and we've successfully completed the problem. So this was a case where, because of the 3x and the x, position made a big difference, and we needed to try it both different ways. So there's our answer, 3x plus 5 times x minus 2.